So if I look at part I, the first part, I have a wooden board leaning against a wall. Supposing the slant of the board is adjusted so it reaches twice as high on the wall. Then it's asking about the slope of the board. So we can see that the height of the top of the board is doubling. So the question is, what does that mean about the slope? So one thing we're going to assume here is that the board is some fixed width, right? And so in other words, when I increase the height of the board, this bottom distance is decreasing. So we can kind of see that in the picture. So in other words, if slope is equal to the rise over the run, we can see that the rise is doubling, and we can see that the run is getting smaller, right? And so so let's look at the, so with that kind of in place, let's look at what's going on here. So would it be exactly twice what it was before? Well, it would be exactly twice if the rise was doubling and the run was staying the same. So it can't be exactly twice, so we can rule that out. Could it be less than twice what it was before? Well, I can see the top part is doubling, but the bottom is getting smaller. So if the top part is doubling and the bottom is getting smaller, then it's getting even more than 2 times. So it can't be less. In fact, it's going to be A. And it's certainly not the same as what it was before. We can kind of see that visually. So the answer there is A. Probably the most common error is students thinking that the slope doubles. But in fact, it can't double because the run part is actually getting smaller. So if the run were the same, in other words, if we had this line where this height was 2x, then that would be exactly twice. But since the run also shrinks, then it's going to be more than twice. All right, number 2, we have an object moving along a straight line. The distance the object has traveled is given by that s of t. What is the average velocity of the object over the interval from t equal 4 to t equal 9? Okay, so when I want the average velocity, I'm going to do the change in position over the change in time. Okay, and so to find the change in position, I want to compute s of 9 minus s of 4. And I want to divide that by 9 minus 4. That will give me the change in position over the change in time. And so to compute that change in position, I'm going to take that 9 and plug it into my function s. And so if I plug that in, I get 2 square roots of 9 minus, and if I plug s of 4, if I plug 4 in for t here, I get 2 square root of 4. And all of that's over 9 minus 4. And so that gives me 2 times 3 minus 2 times 2 over 9 minus 4. So that gives me 6 minus 4 over 9 minus 4. And so what's that? 6 minus 4 is 2. 9 minus 4 is 5. So we get 2/5. And then the units of that are going to be, the distance is measured in meters, and the time is measured in seconds. So the units of that 2/5 is actually meters per second. I guess that wasn't asked, but something you should be able to figure out. Okay, so next, the temperature in degrees Fahrenheit of a 12-ounce cup of coffee at time t is given by this temperature formula. So the little t is temperature, the big T is time. What is the most appropriate interpretation of the statement t prime at 4.2 is negative 9.85? So first of all, let's just think about the units of what we have here. What kind of thing is this 4.2? Well, it is going into the function t prime, so this is a unit of time. This is at time t equal 4.2 seconds. Wait, is t in, oh, t's in minutes, since the coffee was brewed Okay, and then what's the meaning of this negative 9.85? Well, that is an output of my rate of change function, t prime. And so the units of t prime is measured in, well, so capital T was degrees and little t was minutes. So it's going to be measured in degrees per minute. This is a rate of change. It's telling us how the temperature is changing. And so does it make sense that my rate of change in degrees per minute would be negative here? Well, what's happening to the cup of coffee? It's cooling down, right? So this is in degrees per minute. That's my rate of change. That's telling me how fast the coffee is cooling down. So it's cooling down 9.85 degrees for each minute. Okay, so now let's look at our options and see which one matches what we know. So this says 4.2 minutes after the coffee was brewed, the temperature of the coffee was 9.85 degrees Fahrenheit less than the initial brew temperature. So that's not quite right, because we know that that's how fast the coffee is cooling down at that rate, but we don't know that that's the actual change in temperature. So A is out, but it's close. All right, let's look at B. 4.2 after the minutes after the coffee was brewed, the temperature of the coffee was changing at a rate of negative 9.85 degrees Fahrenheit per minute. Yes, that's a winner right there. Let's look at the others and see why they're not correct. On C, it says, on average, the temperature of the coffee decreased by 9.85 degrees Fahrenheit each minute over the first 4.2 minutes. So that would be if we were computing some sort of average rate of change. But this T prime is an instantaneous rate of change, so C is out. It's not an average rate of change. Okay, what about D? The temperature of the coffee decreased by 9.85 degrees Fahrenheit during the 4th minute after the coffee was brewed. So again, that's kind of like some sort of change in Fahrenheit, change in degrees Fahrenheit, but it's not a change, it's a rate of change. So D is out. What about E? It says the temperature of the coffee was approximately 132.1 degrees Fahrenheit, exactly 2 minutes after the coffee was brewed. So it looks like on that one they may have just plugged in the 4.2 to the temperature function to get that degrees Fahrenheit, but that's not really answering the question, so that's out. All right, how about on 4? So now it says, suppose that my derivative, my slope, is greater than the rate of change. Okay, which of the following could be the graph? Okay, so one way to think about this is to think about that f prime of A is the slope of the tangent line at x equal A. And then we can think about this thing, f of A plus delta x minus f of A over delta x as the average, or as the slope of a secant line between the point A f of A and A plus delta x f of A plus delta x. And we're told here that where delta x is greater than 0, and that's an important part here, because what that means is that I'm going to take the x value A, and then I'm going to take an x value to the right of A. So let's go ahead and put those down here. This is A plus delta x. This is A, and this is A plus delta x. I'm just scooting over a little bit. And then this is A, and this is A plus delta x. And this is A, and this is A plus delta x. So we're scooting to the right, and so that delta x being positive tells me that I'm looking to the right of that. So let's sketch in all of these secant lines and look at their slopes. So here is the secant line between those two, like that. This one is going to be something like this. Oops, okay, and then this one is going to look something like that. this one is going to look like this. Okay, and then we can draw in the tangent lines, and I'll just draw those tangent lines with blue. So the tangent line at A is going to be this one. Tangent line at A is going to be that one. Tangent line at A is going to be that one. Okay, and then what I really want to do is I want to compare the two slopes, because what I want is I want the derivative slope to be greater than the secant line slope. So I want the tangent line slope to be greater than the secant line slope. Okay, so for the positive ones, it's pretty clear. We can see that this one works because the blue line is steeper than the green line, and they're both positive slopes. So the blue line has a greater slope. Okay, so the derivative is actually greater than that average rate of change. This one is a no, because here the blue line does not have a greater slope. Okay, so those are the ones where we have a positive slope. Okay, now if I take a look at this one, remember that for negative numbers, bigger means closer to 0. That's kind of the way I think about it. And if I think about on a number line, if I'm talking about negative numbers, where, you know, these numbers here that are closer to 0 are going to be bigger, because bigger always means that we're going to the right. So so that's kind of what we need to keep in mind when we look at these negative slopes. So if I look at this one, I can see that blue line is steeper, or it's more negative than that green line. So in this case, we want that the slope of that blue line is greater than the slope of the green line. This is not the case. So this is the green line, or well, we'll say it this way: the blue line does not have a greater slope. And on this one, I can see the blue line is less steep. In other words, the slope of that is closer to 0 than the green line. So this is true. The blue line has a greater slope. Because for negative slopes, closer to 0 is greater. So the answers then are 1 and 4 only. So that's D. Okay, the next one, if f is a differentiable function and a is a number, f prime of a is given by which of the following expressions? Okay, so f prime of a, so our general one that we use with the h going to 0 is this one. So this is the one we see in the textbook usually. Okay, this one is the limit as x approaches a. And so this is the same, and we can see that this translates to that if we let h equal x minus a, then we've got it, right? Because as h goes to 0, x goes to a, and f of a plus x minus a is actually equal to f of x, and f of a is equal to oh, f of a. So yeah, so anyhow, these two are equivalent, and you can get there by just doing this substitution, and you can see that those two things are the same thing. All right, what about this one? Is this the same thing? Okay, so this looks almost the same as part A, except there is no A in this one. So this actually gives f of f prime of x for any x, but we're asked what f prime of a is. So, so this is not the same as f prime of a, because when we say like f prime of a, we mean like that's a specific x value, that a is like a specific x value, but this is like the function. Okay, so the answers then are 1 and 2, which is C.